In this problem, we are given that in square ABCD, P is the midpoint of BC, E and F are on AB and DC respectively. The side length of the square is 6, and angle AGE equals to 45 degrees. What is the length of side EF? Well, first of all, notice that EF is positioned in an odd place because we cannot use the Pythagorean theorem to find the length, but we are given right angles. So we should use the right angles to help us solve the length of EF. To do this, we have to do some translation. Translation is moving the side parallelly so that EF will become a new line, but these two lines will be equal in length. We just move it horizontally across sides AB and DC. So we can construct the translation of side EF to side AH. So we just translate triangle, we translate EF to AH such that E corresponds with A and F corresponds with H. So by the translation, we will get that EF equals to AH equals to the square root of AD squared plus DH squared. So we become the square root of 6 squared plus DH squared. So become 36 plus DH squared. So our new goal is to find the length of DH. But then we also notice that by the translation, angle EGA will equal to angle HAG because one of the properties of translations are that the new line is parallel to the old line. So this is 45 degrees. But how do we make use of 45 degrees? Well, we want to involve it in a triangle, which we can do by connecting HP. And then, well, there's actually a special property in this kind of figure. So if we just draw a smaller figure, and we only depict the triangle here in the square, well, if we have a triangle here, we can mark it as A, B, C, D still. And mark this as H and P. And this is 45 degrees. Well, the property of this kind of figure is that if we mark DH as A and BP as B, well, HP will equal to A plus B. This is actually pretty easy to prove. In squares, a common method or helping line to construct will be to rotation. So if we rotate triangle ADH such that AD will become AB, then we can call this point as H prime. Well, we want to prove that AHP equals to AH prime P. So we just rotated triangle ADH to triangle ABPH. ABH prime. So we have, they will be congruent, will give us DH equals to H prime B equals to A. And AH equals to H prime. So to prove that triangle AHP is congruent to triangle AH prime P, we need to prove that angle HAP equals to angle H prime AP equals 45 degrees. And we also have from here that angle H prime AB is equal to angle ADH. H prime AB is equal to angle DAH. So since angle HAP equal to 45 degrees, so angle DAH plus angle BAP, we know that this equals to angle H prime AB plus angle BAP equals to angle H prime AP equals to, well, we know that angle DAH plus angle BAP equals to 90 degrees, which is angle DAB, minus 45 degrees. So this also equals to 45 degrees. So since we have from now, since AH equals to AH prime, angle HAP equals to angle H prime AP, and AP equals to AP. So triangle HAP is congruent to triangle H prime AP by SAS. So H prime P equals to HP equals to A plus B. Now, that we know that HP equals to A plus B, so we have HP, and then in this figure will be equal to DH plus BP. And our goal is to find the length of DH. And we can let this as X. So then DP equals to 3 plus X. And then we know that CF equals to 6 minus X. So we can apply the Pythagorean theorem to get 9 plus 6 minus X squared equals to 3 plus X squared. And we can just expand the parentheses. Then after some simplification, you'll get that X would equal to 2. So now that we know DH equals to 2, we have EF equals to AH equal to square root of 36 plus 2 squared, which is square root of 40, which is 2 square root 10. And that is how you solve this problem.